Question 6 is an entropy question, and we're given the reaction of carbon dioxide and water to make glucose and oxygen. We're given the delta H value for the reaction and the delta S value. First thing I want to say, careful with these units because you can see joules there, kilojoules there. That's going to cause some people to make mistakes. So I'll point that out in the calculation when I get to it. We've got some entropy values, and we've got to calculate the standard entropy of glucose. So the entropy change, the delta S for this reaction, this -256, that is calculated by getting the sum of the entropies of the product and taking away from that the sum of the entropies of the reactants. So within the entropies of the products, I've got my unknown term, the glucose. So you can see there's the solution there. So the combination of the entropies of the products would be that with the unknown in, and then separately from that minus, there's the sum of the entropies of the reactant, and you feed those numbers into your calculator, rearrange, and you should get X coming out at 218. Calculate delta G at 25 Celsius, and it's got to be in kilojoules per mole, so that entropy has got to be converted from joules to kilojoules by dividing by 1000. Temperature, remember, has to be in Kelvin, so that needs to be converted, so we need to add 273 onto 25, that's where the 298 comes from. So Gibbs equation, delta G equals delta H minus T delta S. Feed the numbers in, and you should get an answer of 2955. Why is the reaction not feasible at any temperature? So we need to explain why delta G can never be 0 or negative. And that's because delta H is positive, delta S is negative, so that means you've got negative times negative, which becomes, this term just becomes positive. So all of this will always be positive. So delta G can never be negative. So it's not feasible at any temperature. And then the question turns quite nasty with this calculation. It's not very nice. Although the reaction between carbon dioxide and water appears not to be feasible, plants are able to make the reaction take place spontaneously by photosynthesis. So each year, this many kilojoules of solar energy is taken in by all the plants on Earth to make photosynthesis take place. Calculate the mass of carbon dioxide that is removed each year from photosynthesis. So the way I've tackled this, we were told at the top of the question that the enthalpy change for the reaction was this. We're told that the annual energy taken in by the plants is that much. So if you divide that by the enthalpy change for one reaction, you can work out that there are that many reactions, that many of these reactions take place every year. Ultimately, we've got to work out the mass of CO2 that's absorbed. So if there are that many reactions take place, there are 6 times that moles of carbon dioxide. So I've multiplied the 1.18 times 10 to the 15 by 6. So we've got that many moles of CO2, and now we multiply by the MR of CO2, which is 44, and it comes out at 3.12 times 10 to the 17 grams of CO2 per year. And there's the solution. I've written it up there.